Hey, what's up? I'm Sam, and today we're going to be test driving the stack data structure. Alright, so let's see if we can figure out this stack data structure together. And if you're new to programming, you're still in school, I'm hoping this video would be helpful in not only understanding the stack, but also give you some tools to learn test-driven development and to work iteratively. If you've been in the industry a while, maybe this can offer a fresh perspective and improve your test-driven development skills, or maybe introduce you to them. So we'll see. All right, so diving in, what is a stack? The easiest way that I like to think about it is a stack of plates in the kitchen. So when I'm unloading the dishwasher, I take one plate by one plate out. I usually stack them in my hands. I'll grab like 4 or 5 of them. I'll take them over to the cabinet, put them in the cabinet. All right, and then I get hungry. I go in, I get a plate off the top, and I put some food on it and I eat. So that's basically a stack in a nutshell. The first plate that I grabbed out of the dishwasher was on the bottom, and then I kept stacking them on top, and then I put them in the cabinet, and then I grabbed the one off the top. So the last one I put on the stack of plates is the first one I use, and you'll hear that as like last in, first out, which is kind of it's not the opposite, but it's different from a queue, which we'll do that one in another video, but that one's first in, first out. So that it's real simple to understand, and I think the tricky part is just translating that to code, but that is the job of a software engineer. So some real world applications are undo, redo functionality. If you've ever seen like the matching parentheses programming problem, that's a stack problem, and like back and forward buttons in the browser, which is kind of the same thing as undo, redo. Yeah, so here are the functions that we are going to be implementing, and we are going to work iteratively. We are going to run the test a lot. We're going to take one step at a time. We're going to put one foot in front of the other, and we're going to build this thing up. All right, so let's get going. So push adds an element to the top. Pop removes that element from the top. So it's taking the plate to get something to eat. We can check to see if it's empty. We can check to see if it's full. That implies that there is some size constraint or parameter that we can add. And the top, so I'm looking at the top of the plate, but I'm not sure if I'm gonna grab one yet. So I'm gonna look at the plate, but I'm gonna keep it there. Yeah, so where should we start? I like to start easiest way possible so I can start building these up. So I think I'm gonna start with this is empty. And you'll notice that if you watch the previous video, I had a list of functions, but a stack is going to have some internal state. So whenever you're using some type of state, I like to use a class in that scenario versus like a stateless function. I'll just use a regular function. And when I'm reading my code, if I see a class, then I know that that class has state. So that is a mental cue to me that I know that this thing has state. If I see just a regular function, then I know it's stateless and I don't have to worry about state. So it's just a little convention that we do at our organization, but it may differ from organization to organization. Cool. All right, so let's get going here. Void is empty, should it should probably return true for a new stack. So we're not going to be initializing the stack. We're just going to with any like elements up front, we're just going to say a new stack is empty. So say stack, new stack, expect stack dot is empty to equal true. All right, and we have compilation error. Obviously, we haven't made a stack yet, so I'm not gonna run this test in this case because I know it's gonna fail. So class stack is okay. I'm just gonna return true right here. Hard coded for now. Cool. We're green. So although we're just hard coding, that just like gave me the fuel to create the stack class and to start getting this interface defined. So I'm just gonna copy this and so I could do the is full next, but I know that that's going to require a parameter and I don't want to make things more complicated than it need to be. So I'm going to start looking at these other ones right now. So I'm going to start with the push, and this one's going to get a little tricky, and I'll show you I'll show you in a second. All right, so push should add an element to the top of the stack. Okay, so how am I going to test this? Okay, I can't peek into the stack and look at its internal configuration. I need to be able to look at things from the outside. That way I have the power to refactor and not lock myself to implementation details. So I think what we could do is push a couple elements to the stack, and then we can call top. We haven't written that yet either, but if I call top, it should return the last one that I added, and then we will know. So let's try that. So stack.push. Okay. Stack.push. You can't type today. All right, and then yeah, so we can expect stack.top to equal you. Okay, so push is red, top is red. Let's go in and implement those. So public push, and we will say this is an element. I'm gonna keep these strings for now, and in a little while we'll make this generic. So probably I need something to hold this stuff internally, so I think I can use an array here. So I'm just gonna say like this data store push element. All right, and then we're gonna make that data store private read only. I like doing this private read only thing because I'm saying number one, it's private, so no one else can use it. It's hidden from the external world. And then read only says that this is immutable. So it's basically saying like it's a const, so no one can reinitialize this out from underneath this. Okay, and then so we need a constructor. And then we'll say this dot data store. It's empty when we start. Okay, so that looks good so far. And then we can also say return the last element. So we'll do this dot data store, and then the index will be this dot data store -1. So that'll give us the last element. That link. All right, let's see if that works. Cool. We're green so far. All right, so we kind of did something cool here. So we did push and top. So we kind of got the top for free because we were doing like a state-based testing, right? We're pushing something and we're getting something back out. So that's something to keep in mind when you're going through these things. There's like a common notion in like Java unit testing. It's like, should you test getters and setters? And a lot of times you test them implicitly, so they don't require explicit tests all of the time. Sometimes you can add them in there just for the sake of documentation, but in this case, we're actually implicitly testing the top function as well. Yeah, so just something to keep in mind. All right. So that's push. So I think next we can do pop. So pop should remove. I'll say this. Let's split this into two. So it should remove the topmost element, but what does that mean? It means it should return the top element and then the next one will be it should remove it. So splitting those into two test cases just keeps your test a little bit cleaner. General rule of thumb is you want like one assertion per test. That way, if something breaks, you know specifically what broke and where. So if you have a bunch of assertions in one test, you can get into situations where you really don't know what broke because you are looking at such a vague picture of the thing. So you want to try to isolate as much as you can. Pop should return the top element. So I'm going to change these a little bit just to add some variance to our test cases. So I'm going to push. This is stack. All right, and then we're going to say pop instead of top. And that should work. Okay, so I'm actually going to just copy top for now. Bam. Okay. All right. So now we can do the second part, which is it should remove it. Right, and this test case is like pretty much what separates the pop from the top functionality. So when we go to write our top test case, it's going to be copy paste from here. All right. So how do we test this? So remove the top element from the stack. So if I call stack.pop, and then if I do stack.top, is should be the top element on the stack. So I popped this one off, and now I want the top element should be this one. Okay, failed. We know it should fail in this case. Okay, so pop needs to do something different. Is there a pop functionality on? Okay, there's actually a pop on the array in JavaScript. Let's see if that fixes it. I think you could also do this with like slice or something. I don't know, I'd have to look it up. There we go. All right, so we got push, we got pop. Let's do top real quick. So we don't need this one anymore. So I like to just add like a little bit of variance between cases. So keep it simple, but just add a little bit different flavor to each one, just to, you know, that you could technically like hard code this to be specific to this and it not work in the real world. I don't know exactly how you would do that in this case, but for the sake of just trust me on this one, add a little bit of variance. It'll keep your tests healthy. All right, so this should pass because it's the same functionality, and we already know what it does. Cool. All right. And before we go to the is full case, let's kind of go back and look at this is empty. So should return true for a new stack. And then we could do return false if elements have been added to the stack. So let's say stack dot push Luna, and so this should equal false. Fails because we had this hard-coded, so let's refactor that. So return this data let's see, so if it has anything in there, so if this equals 0, then it's empty. I don't even think you need this boolean. Cool. So we're good there. All right, I think there's one more here where it's like I added stuff and then I removed it. So return true if all elements have been removed from the stack. So we can do stack dot push and then stack dot pop, and then this should be true. Cool. We're all green. And this first test case, it helped us get started. But what happens if we come in and we say, actually, I want people to be able to initialize this stack with like a given data set. So I'm gonna pass in an array and create a stack from that. Then we can just delete this test case because this is no longer true. So if the behavior changes, don't be afraid to delete tests. I think people are like scared of deleting tests sometimes, but if you need to, do it. All right, so we got pop, top, push, and right now let's focus on is full. All right, so describe. Is full should. All right, so it should return false if there's space left in the stack. So what does that mean? That means we need to pass a parameter, a size parameter, right? We're gonna say this thing can hold 10, and we haven't pushed anything, so we should expect stack dot is full to be false. What? All right, so we don't have this yet, and we don't have this yet. So let's start with the first case. Okay, so we need to add this parameter here, but I don't want to break everyone. So I can make this optional. So we can say size equals 100. And we're gonna default it to 100. And then we say this dot size equals size. And then this will be private, read only, size. Okay, so we're no more error here, and then all of our previous calls are okay as well. So we refactored a parameter in here without breaking our other callers, and that's important because now we don't have to go across the code base and change everyone. We can just change it here, add new functionality without breaking everyone else. All right, next we can add is full. All right, and we can say if this dot data store equals, sorry, this dot data store length equals size, then we know we're full. Cool. So that one passed. So what's the true case here? Return true. If the stack does not have any more capacity. So if I make this a stack of 1 and I push something onto it, then it is full, and this should equal true. Laptop is working so hard right now. All right, we are green again. Cool. So we have like all of the base functionality in, and yeah, this is probably like a good first cut, but I'm noticing there are some potential like error conditions. For instance, what happens if I push to the stack and it's full? What should happen? Should I let people keep pushing to it? Should I throw? Should I just not do anything and kind of fail silently? Maybe I could log. So we're faced with a design decision here, right? We have like the base functionality in, but how do I handle these kind of edge cases? So I'd probably throw an error here, right? If you're pushing to something and it's full, you can't push any more to it. You could like fail silently, but that's not good either because you're kind of just kicking the can down the road. So let's say I push the stack and then later on and I'm using it and I need to pop off the top, and I'm like, wait a minute, I just pushed something and now I popped and that thing I added is not there. So that's just creating more headache later. So I prefer to fail really early, and if it's an error condition, let's just throw. So the error condition there is it should throw if the stack is full. So I'm gonna create a stack of size 0 or 1. I'm gonna add one thing to it. I'm gonna try to add to it again. So in this one, I should expect this to throw an error. So we could say, we can specify like a specific error. We say stack full error. All right, so we don't have this error yet, but we can make it. So let's see if we can do that real quick. So push if this dot is full, throw new stack full error. All right. And yep, looks good. So if it's full, it'll throw. If it's not, it'll keep going. So let's just create this little error class right here. Class extends error. All right, you can leave it just basic for now. All right, let's see what happens. Ooh, we got a failing test. Okay. Oh. Okay. I always get super confused that just and these that do this. So sometimes you gotta arrow function these. I'm pretty sure there's a way to not do this. But yeah, this should fix it. There we go. Yeah, because it wants to like call a function in here. And since you were before, like we were calling the actual function, but you need to pass it a function. So it will call the function and then throw. If that makes sense. I hope that makes sense. Okay. What other kind of funky cases do we got? So we got push when that. What happens when we pop and there's nothing in the stack? So stack is at 0 and I pop. So we could throw an error. We could say there's nothing to pop, or we could return null, or we could return undefined. Probably makes sense in this case to return undefined. Because you could be in a situation where you want to keep popping things off the stack until there's nothing left. And sure, you could catch that in error, or you could say, if it's undefined, I know I'm at the end. Let's do that. Return undefined if there is nothing in the stack. Okay, new stack. Pop. This should equal. I think this is JavaScript's default behavior anyways, so that probably line up. Cool. All right, and then we'll do the same thing for top as well. Cool, we are good there. All right, so I can't really think of any other cases. So if I push and it's full, we're throwing an error. Use topmost element from the stack. If we get to the end, we're going to return undefined. It's empty, yes or no. It's full, yes or no. Top, display, return undefined. Okay, the only other thing I can think to do is to make this generic. That way it doesn't work for just strings. So do that by making this generic here. This will be T. All right, and then everything else should be the same. Let's run our test just to make sure. Cool. And if we wanted to like add some more variants to the test, if we would have done this earlier, we could have added, you know, numbers, objects, could have done it with different elements in the stack. I don't think that's necessary in this case, but if you want to experiment with that, go ahead. Yeah, so I think that about wraps it up here. Gonna do the refactor here to move it to its own file now. Move to a new file. All right, there we go. Cool. That's a wrap on that one. Let me know if you have any questions. I think this was a cool example because it kind of shows you like the state-based testing of using existing functions on the thing you're testing to kind of get things in or get things out and put stuff in. So you're kind of back and forth, moving around a lot to kind of fulfill the whole use case here. And this one's interesting because it has like a couple error conditions as well. Yeah, let me know what you think. If you have any questions, reach out, and I'll post the link to the repo in the description. Peace.